Hey everyone, and welcome to this explainer. Today we are looking at something really exciting. We're diving into PRISM, which is a platform that's fundamentally changing how enterprises actually deploy artificial intelligence in the real world. We're talking about a completely paradigm-shifting, governance-native, agentic-as-a-service runtime. Basically, it's an architecture built from the ground up specifically for enterprise C-suites who are, and rightfully so, deeply concerned about AI liability. Okay, let's dive right into this. We are going to deconstruct the PRISM architecture from its brain all the way down to its conscience. As you can see on the agenda, we'll quickly cover the unconstrained liability problem, then tri-model cognition, sandboxing and execution, constitutional policy, and finally, unbreakable identity. Let's get right to it.
All right, part one, the unconstrained agent liability. This really sets the stage for the core conflict enterprise architects are facing today.
So if you look at unconstrained open source agents today, they are frankly massive liabilities. We're usually dealing with standard sequential frameworks that just get trapped in these endless hallucination loops. They suffer from really weak governance, and worst of all, they leave untraceable actions. PRISM replaces that whole mess with its parallel tri-model architecture, cryptographic enforcement, and truly deterministic workflows. Honestly, this isn't just some nice-to-have tool anymore. It is an absolute necessity if you want enterprise safety. To really grasp why those standard single-agent loops fail so hard, just look at this quote from Kirk Lassell. When a single model generates planning, writes code, and validates its own execution, it operates inside a closed echo chamber, inevitably validating its own errors. It's like a giant puzzle where the pieces are all wrong, but the system just keeps telling itself it looks great. When the exact same model that made a mistake is asked to check its own work, it just confirms its own bias. And for an enterprise, that bias could literally mean a catastrophic code deployment or a massive compliance violation. PRISM's parallel tri-model fan-out offers far superior reasoning, specifically because it shatters that dangerous echo chamber.
And that brings us perfectly to part two, tri-model parallel cognition. This is the brain of PRISM, and I'm super excited to show you exactly how it solves that echo chamber problem.
Enter a concept called spectrum refraction. This is PRISM's novel tri-model parallel fan-out orchestration system. Think of a physical prism splitting light. This system refracts a single prompt into three completely distinct cognitive perspectives, and it does this simultaneously. And this brilliantly illustrates the power of mandatory instance isolation. PRISM literally enforces rules that reject configurations where the models are identical. That guarantees true multi-model diversity, so the system is never just talking to itself in a loop.
So here is how that orchestration actually flows in practice. On one side, you've got the left hemisphere. That strictly handles logic, reasoning, and code using powerful T3+ models. At the exact same time, the right hemisphere focuses on creative synthesis and vision. Then, acting as the ultimate judge, you have the main coordinator. The coordinator evaluates outputs from both of those hemispheres, resolves any contradictions, and pulls together a final, validated payload. The absolute key takeaway here, all of this generation happens in parallel, not sequentially.
Now, you might be wondering how it all comes together without being a jumbled mess. Unlike standard sequential agent frameworks like Crew AI or LangGraph, which often just blindly concatenate or paste outputs one after another, PRISM does something much smarter. It uses XML-tagged structured aggregation. So the main coordinator receives perfectly tagged XML sections from both the logic and creative models. This forces a unified, deliberate compound synthesis. The benefit here is huge for complex decision-making because the main model actually has to deliberately synthesize those distinct perspectives, rather than just blindly pasting text together. All right, moving from the brain to the hands of the platform. Section 3, ironclad sandboxing and execution. How does PRISM actually touch the real world safely? Now, what's really interesting about this slide is when we compare the resource isolation of PRISM's container sandboxing directly against standard Docker-first execution models. The difference in safety is night and day. Open source agents usually run with incredibly weak metadata limits, which leaves your host completely vulnerable. PRISM, on the other hand, steps it up by using hardware-level OS groups v2 quotas to strictly enforce resource isolation. Plus, it features snapshot and revert recovery semantics instead of just destroying and rebuilding containers, and it executes everything through a virtual PTY terminal rather than exposing a raw host shell. You can kind of think of these execution safety features as literal layers of armor. First up, that virtual PTY terminal session completely blocks unsafe shell mutations, things like sneaky nested deletions or unauthorized downloads. Next, we have the CSH baton pass.
If an agent tries to do something high risk, it just stops. It pauses execution and waits for human visual approval, literally passing the baton to a person. And finally, my favorite, visual PII masking. Whenever it takes screenshots for vision models, PRISM uses a local OCR filter to aggressively redact credit cards or any sensitive data before a single pixel ever hits the cloud. That is a groundbreaking standard for corporate compliance and data sovereignty. Okay, we've seen the brain, we've seen the hands. Now let's examine the conscience of the platform. Section 4, Constitutional Governance and Policy.
Meet the Constitutional Causal Compiler, or CCC for short. It's a pre-execution compiler that takes the agent's intent, your system's policy, past memory, and the current context, and transforms all of that into a heavily constrained, totally safe execution plan graph. Basically, think of the CCC as an incredibly strict project manager. It maps out every possible misstep and blocks it before the agent even lifts a finger. By pre-computing these paths, the Constitutional Causal Compiler strictly enforces governance and drastically reduces any unsafe branching during high-risk operations, again, before the execution even begins.
Let's move to the next visual and see how this builds out. This compiler feeds directly into PRISM's 3-tier policy engine, which guarantees enterprise-grade security for automated operations by distributing load based on actual risk. So roughly 60% of tasks are Tier 1 autonomous, meaning low risk, mostly read-only stuff. Then 25% are Tier 2 conditional. But it's that final 15% you really care about. Those are Tier 3 approval-gated actions. These are the high-risk operations that mathematically mandate explicit human sign-off. Governing all of this is something called the Permanent Active Directives, or PAD. These are 10 completely immutable laws enforced by SHA-256 cryptographic hashes, and they are constantly checked every 10 minutes by a totally isolated guardian agent. And actually, here's a wild fact. PRISM CI Gate 9 will entirely block software releases if the SHA-256 hash of these 10 laws doesn't perfectly match the hard-coded runtime constant. There's literally no way around it. The system cannot modify its own constraints. All right, rounding the corner here. Part 5, Unbreakable Identity and Accountability. This is the final layer of the PRISM Fortress. So every single agent is bound by Character Accountability Control, or CAC. And guys, this isn't just a basic username. It's an unbreakable chain tying together the character ID, the specific user and operator emails, all the way down to the exact client and session IDs. So the crucial point is that this completely eliminates anonymity. It ties every single machine action to a very specific human operator. Character Accountability Control enforces this identity integrity across all agent lifecycle transitions, whether that agent is just being spawned, if it's suspended, or if it's completely revoked. And this identity chain becomes incredibly important when we talk about swarms. When a primary agent spawns nested sub-agents, say in a star or mesh topology, the budget limits and security constraints are mathematically inherited by those child agents. This is a massive deal because it actively protects enterprise budgets and limits liability by physically preventing those runaway swarm loops that could otherwise drain your API tokens or cause a massive compliance violation. Which leaves us with one incredibly provocative question for you to think about. Who truly controls your autonomous systems? As we've seen today, if you aren't using cryptographic moats, parallel trimodal architecture, and rigorous identity chaining, well, your systems might not really be under your control at all. PRISM proves that safe, enterprise-grade AI deployment isn't just some far-off goal, it is something that is mathematically enforceable today. I really hope this explainer sparked some fresh ideas on how we govern the future of autonomous systems. Thanks so much for joining us.